The Memorial Loop project redefines movements through urban spaces and experiments virtual reality as a tool of design, visualization, and presentation. During COVID-19, the design process tests various tools for virtual collaboration while social distancing. The main topics we investigated and will be covered in this presentation are 1. The VR presentation and precedent studies. 2. Our design proposal for the World Trade District. 3. The virtual reality experience. 4. The virtual reality design process. 5. The user experience. 6. The tools we use throughout the project. In the beginning of the semester, we analyzed the vertical and horizontal circulation of tall buildings and cities. Analyzing the Hong Kong skywalks and the Marina Bay complex in Singapore, we explored systems of horizontal movement at higher levels. While one of the main constraints of tall buildings could be the lack of horizontal movement, both of these systems are able to recreate ground-level pedestrian experiences at higher levels. Analyzing precedents of car and bicycle movement, such as Paul Rudolph's Manhattan Expressway, we explored ways of weaving distinct transportation typologies into a single infrastructure. These study models and precedent studies are collected into an exhibition located in the main lobby of the final design. You can visit this exhibition in 3D space and can grab and pick up the models in VR mode. One of the striking characteristics of the World Trade site is that it is disconnected to other districts, and it is bound by the West Side Highway, an 8-lane highway blocking pedestrians from crossing the street and reaching the harbor. We create connections above the ground to bridge the highway and connect the riverfront to the World Trade District. Then we expanded it into an interwoven loop of pedestrian, cycling, and people mover paths that connect towers around the World Trade Center into a horizontal and vertical transportation system. Our goal is to create observation points framing around Ground Zero from the surrounding buildings, visible from the transportation loop. Public spaces such as restaurants, winter gardens, and galleries are inserted onto the balcony, rooftop, and lobby spaces of the context buildings. Skywalks are designed to link our new towers to these spaces, and they together form an elevated ground plane that connects the World Trade District across the West Side Highway and to the harbor. The lower level of this circulation system loops around the World Trade Memorial and creates views of the memorial from all perspectives. The system also expands vertically to join towers at a higher level, providing shortcuts for office workers and tourists to move between buildings without having to exit the building at the ground level, re-enter, and move vertically, which at the same time reduces the crowd on the ground level. The 3 new towers we inserted are points of arrival to this 3-dimensional circulation system. They link the skywalks down to the ground level, the train hub of Calatrava, and the Battery Park City Ferry Terminal. Cars are left by drivers at the base of towers and then are sent up to parking slots on the car facade by car elevators. The front facades, together with the visually lightweight structure, form a gateway for pedestrian arrival. The towers also provide vertical circulation, connecting paths at different heights.
In the virtual pinup space for this project, we provide 2 virtual headsets for users to experience the movement through this complex. We call them virtual experiences. Such experiences help us understand the feeling of spaces and improve our design. The first experience, the pedestrian experience, is the story of visitors arriving at the complex from Midtown New York from the north. It's choreographed within Gravity Sketch and imported into the Unreal Engine. Upon arrival, visitors first see the car facade as a gateway. It showcases the front faces of cars and has become a landmark. It's also an awesome background for photos. The street, which intersects with the pedestrians coming from the northwards for cars, so the design moves the street up to ensure uninterrupted movement for both cars and people. As a result, visitors can safely stop here and observe the moving car elevators above them. The VR experience in return improves our design. Arriving at the center of the complex, we can now see the other entry from the east direction, where a church is located. The ground slopes down to the subway station platform, and the Calatrava architecture is framed in the view. For better viewing of the memorial, our tour guide suggests us to get onto the memorial loop on the upper level. The memorial loop draws visitors all year round. The gallery, where our final review is located, attracts tourists. People living and working nearby also enjoys visiting the exhibition, and they could come to the suspended theater for shows as well. The people mover system is inserted in the bridges to help people quickly move through this urban complex. It threads through the winter garden above the harbor. The restaurants, the main lobby, and other public spaces were inserted on the contact buildings. This experience allows users to drive a people mover capsule on their own through the spaces and enjoy the nodes along the track. In the current industry, VR is mostly used as a final representation tool. Our goal was to integrate VR early into the design process. From the precedent analysis to generalizing the connection diagram, then to populating the diagrams with people, plants, and programs, we used Archeo, Gravity Sketch, and Tilt Brush. Moving to the design phase, we continue to use VR for spatial design. The site analysis, the massing design, and the bridging schemes are all drawn in VR. Such intuitive sketching allows us to design from within our spaces and experience the design in real time. The multiplayer aspect of Archeo allowed us to collaborate on the same sketch and quickly iterate and discuss design options. Moving to the scale of lobbies, we continued the process of the following 4 steps: 3D sketching and designing in VR, experiencing the scheme and annotating in VR, importing the annotated sketch into Rhino and developing a precise model by tracing the geometries, importing the precise model into sketching programs again to paint the interior, vegetation, and mood. By repeating the steps multiple times, we improved our design and enhanced the experiential aspect of it. VR sketching is also used for choreographing the stories happening in the spaces, which inform us how the spaces feel like when it's occupied and help us make design decisions. We have created a virtual experience in Unreal Engine to communicate our design ideas. The first step of developing a smooth experience is to teach users how to navigate in VR. In the experience upon arrival, users first learn how to swim through spaces with controllers and then practice teleportation, which is the main method for movement in VR. Features such as menu, grabbing, animations, and minimaps were implemented with blueprint coding that helps users better understand the design scheme and experience it. The diagram models in the pinup space can be grabbed with controllers for closer inspection. The menu attached to the left hand contains a minimap that helps users teleport to target locations. The menu also provides sliders for controlling the sign position and is used for analyzing lighting conditions. Time travel is also allowed in the virtual environment, as these 4 buttons bring us to the 4 phases of the design process. While we understand that not all users have a VR headset, we developed key features for desktop mode. We also captured 360 panoramic images of the key moments and shared it on ArtStation for immersive experience with mobile devices. Additionally, this video itself experimented with mixed reality for representation.
These are some of the tools that we learned how to use along the way and helped us collaborate.